Hello.
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 Hello, Ananya. Yes. Can you hear me?
I can.
Let me get the okay, Ananya. Today, are we trying to finish up the astrophysics?
Yeah, I think so.
Okay, let's try that. Let me get a headset. Um, the last time we talked, you can okay, board. I remember that there's some things missing from D2. Okay. Yeah. Page 62, right?
Yeah.
Okay, all right. Okay, so I'll share my screen. Uh, we are leaving this part, which is the distance measurement, and we are going to this stellar evolution. Okay. At this point, there won't be much formula. There'll be one or two numbers or limits, but mostly it will be, or like a better words, it's like biology. I'm sorry, do you take biology now?
No, I don't.
Geography? No, geography, no.
I take history.
History. Well, this is the history of a star, lah. I guess that from, yeah, maybe you can see it that way. The point is, this is no longer the formulas that we're used to, right? So, I will go, I'm sorry. This part is again, is different. Forgive me for assuming that you may actually understand this more than the previous one. You correct me if I'm wrong. Do you understand this somewhat?
Listen what?
This one, this part, this section. Do you understand this a little bit, or do you want me to describe it in detail?
I think if I read through, I can probably understand it.
Okay, then I'll give you the important points and see how it goes. Okay?
Yeah, okay.
Yeah. So this slide, I'm sorry. This slide simply means that, okay, a star is a condensed thing, put it that way, yeah, in the vacuum and emptiness of space. This cloud of dust on the right are not as dense as the star. The dust can actually gather and become a star, keeping it as simple as possible. How come the dust gathers instead of spreading? That's what we usually observe in our in daily life. Smoke don't usually gather, smoke usually disperse, right? Yeah. Okay. But the dust in the vacuum of space, well, have no air to disperse them. That's one. Secondly, have something that gathers them. That something is as simple as gravity. So they're asking you to imagine in millions and millions of years, this dust would have condensed into something smaller, denser. Basically, they will float into each other. That's the start of a star when it is not yet a star. Making any sense? Okay, right. So this is what? Oh, they go very fast here. Oh my goodness, they go very fast here, isn't it? Which means they don't want to explain too much. Yeah. Okay. Okay. So I confirmed that already. All right. So let me skip a little bit to the next two slides and then I'll come back. Now here. He's saying that finally there's a nuclear fusion that is happening. At this point, we know of a star, so our sun will be having this nuclear fusion happening, all the lights and all the heat, right? Something happens, something else is taking place before the nuclear fusion. Something else will be this thing. So when the cloud of dust, they're actually not dust, they're mostly hydrogen and helium. When they combine to each other, they will reach a point where are dense enough to do this, to do ionization. I mean, keeping it simple, they are bumping to each other more. I mean, keeping it simple, they are bumping to each other more. So ionization will happen. Ionization is simply me losing my electron. Ionization will happen. Therefore, temperature will increase. I'm sorry. Bumping to each other, ionization will happen. Temperature will increase because they are bumping to each other. Why? Because they're getting closer to each other. And you will start to shine a little bit more brightly. You are not very dark anymore. You're not very dark. You are now generating your own heat. Your own light. Heat also in the process. This is not a star. You call this the protostar. Proto simply means before star. Before star. Okay. How hot is this? This one, blah, blah, blah. They don't bother to explain how come this hot, how come not that hot, and that kind of thing. Okay. But what makes sense is as simple as protostar is greater, greater. It's larger than the sun. Larger than the sun, even though its mass is equal. If that makes sense to you, you roughly know what's going on already. So does it make sense to you?
Yes.
Then that's a protostar. Okay. Do you know why 100% is luminous? Remember, luminous is the absolute brightness, right? The thing that you get if you measure everything, right? So a protostar is much brighter than the sun with the equal mass. Equal mass simply means equal substance, equal substance. So Oh, yeah, Daniel, I can see you. Can you hear me?
Hello.
Yeah, Daniel. Okay, I can see you. Can you hear me?
Yep.
Okay, all right. Okay, Daniel. Yeah, I'm just doing stuff with Ananya. Daniel, for today, are you going to ask questions?
Yeah, I got a bunch of math stuff on it too.
Then I'll go to the math one first, yeah? The math check. Okay,
Just give me
okay,
a
I'll
sec.
just be
I'm getting
waiting.
everything set up.
All right. Then I'll continue and alternate between you.
All right.
Yeah, in the Jamboard. So, he is brighter than the sun. You may ask questions like, it's not even a star. Then it's already brighter than the sun. Why bother being a star? Because the protostar cannot help it but become a star. This is what they mean by the evolution. He cannot actually stop the process. The reason why he cannot stop the process is because of gravity. It is really the only reason. The gravity of such a big thing keeps collecting them and making it denser. There is nothing to stop gravity at this point. So he's not concerned that I'll be less bright. I don't want to be. I want to stop. I don't want to continue. The continuation of this process will sometimes end up being a black hole, for example. I don't want to be a black hole. Nothing can stop that because gravity cannot be turned on and off. You will see gravity to be, to always be referred to as the reason. Okay. Again, basically the dust is compressing themselves. This is not what we observe in daily life. This only observed with such huge amount of dust in this case. All right. Am I making any sense so far? Okay. So we are at the end of protostar. Protostar is something like that, something less dense than our sun, something bigger than our sun, something that can be brighter than our sun. Fair enough. And then he continues squeezing himself. Gravitational contraction continues. The act of simply being compressed. Okay. Now, the high temperature. Oh dear. Oh yeah. Okay. This is the first time you mentioned plasma. I explained plasma this way. So plasma is as simple as something very hot, right? So that the electrons are straight. That's not the most important thing. The plasma is so hot that it flies very fast. Does that make sense to you? Something very hot, gas, will fly very fast. If that makes sense, because he's flying very fast, a few atoms will be able to fusion, because flying very fast makes you able to squeeze into each other more. And finally, the major squeezing, fusion, takes place. The fusion is what we usually learn in the same fusion that we kind of learn in the fusion chapter, the fission and fusion chapter. There's nothing so too different than that in IB year 6, right? And that is where you officially becomes a star. Okay. Now, I did say something that something like this: gravity, nothing can stop, nothing can turn off. Now, this is where the first time I will mention that gravity is being resisted. So it's not turned off, it's resisted. Gravity compresses, but the pressure, radiation pressure, what is that? Let me just explain that in the simplest way. I mean, fusion can be thought of as an explosion. Explosion, obviously, expands. Gravity compress. So gravity is pressuring at one direction. The radiation pressure caused by the fusion is expanding at the other direction, and we have a balance. Somebody can fight the gravity and the star no longer collapses further. This is one of the things that I think they want to ask you. What stops the star from continuing to evolve, from continually changing to something else? Well, you quote this lah, the radiation pressure. Am I making any sense right now? Okay, Daniel, I'm seeing. Let me change the. Okay. Am I making any sense right now, Alan?
Yeah. Yeah.
Let me skip a little bit and then give you something to prepare. Now, again, I'm explaining to you that something is currently fighting the gravity and stopping the further collapse. I mean, I will show you in the slide. There you go. There you go. There you go. Okay, so I skip around 8 slides and then I show you he is now interested in something, what happened when the fusion ended. So the fusion can end because the fusion needs a field. The field will finally expand itself, right? Not in our lifetime, but the sun will eventually stop fusioning. Something happens after that, which always again has something to do with the gravity. Something has to do with gravity. Okay. One of the reason is, so this is what they will explain, right? So I'm asking you, Ananya, to read from page 51 until 56. No? We'll discuss that. No. So what happens during the fusion process? Okay, Ananya?
Okay.
Fine.
Let's do that for all of them. Okay, for you, Daniel. Okay. I have this in page 16. Yeah? Daniel, correct me if I'm wrong. The calculator, you can always use one. There's no restriction. Yeah. Okay, I understand. Right. Okay. So, okay. Would you like me to differentiate this? This guy's the problem, isn't it? Oh, I know. This guy's the problem, isn't it?
Yeah.
Isn't it? That guy's the problem. Yeah. Okay. So easy to solve. Easy to solve. Let me show you. I'm solving it by, well, avoiding log base 3. In fact, I'm avoiding every other logarithm. The only logarithm I want is natural logarithm because that's the only thing I know how to differentiate. I am using a logarithm rule. Am I making any sense right now?
Yeah.
All right. Now you look at my new thing. Is it differentiable? Is it?
You just change your base.
It is just a change of base, exactly, into what we can do. That's the only trick necessary. If you differentiate this, you will most likely get this. Would you like to try yourself, or I can do the first few steps? You choose. All right. I will make one last recommendation that this guy you take out. This guy simply take it out so that it doesn't bother you. If that makes sense. It's just a number, man. Focus yourself on this thing over there. You focus on this. This is just a number. You can put it in later. Okay, Ananya, take out. Nanya, are you at page 51? Have you progressed?
55.
50, oh, okay, very fast.
Hmm.
55 is your first branch. Is your first branch. If you don't understand 55, I will be glad to explain.
Isn't there a formula I can use for this?
Let me go. Let me check. Oops.
There is.
Please don't do that. Please do this. Please do this. No formula. Please do this. This one does not require formula. Do this. In this case, instead of a formula, you'll be needing the quotient rule. Would that be okay? This is the U, this is the V. No? U prime, V prime.
That seems unnecessarily hard.
I can tell you that it is not. I can tell you that it is not. It's not unnecessarily hard. That one I can tell you. Next one. U prime V minus U V prime over V squared. I hope that the square kind of motivate you since the answer key seems to have a square. Ananya in the Jamboard. Page 6, yeah, page 6. We start with the cloud, right? Mostly H and HE, right? Gravity does its work. It will become a protostar. What differentiates the cloud from the protostar is not that it's dense or more dense, but its luminosity. Finally, the protostar is glowing. We can say that. Is the cloud glowing or not? We pretend that it's not glowing at all. We pretend that it's totally dark. We just pretend, right? Okay. Then the protostar will, well, become a star. We call it the main star, the main sequence star, whatever, the usual star that we have. If it is too small, brown dwarf. And if it is too big, if you could tell me, what does it become?
It disrupts the evolution of the star.
Yeah, for some reason, it becomes a question mark. Basically, it explodes. It explodes further. So what does it become? Don't know, but it is not gathering very successfully. It is not. This one, still gravity, right? Gravity doing its work to do fusion. So gravity causes fusion, and at the same time, fusion fights against gravity. Making any sense? Brown dwarf, gravity not enough to do fusion. That's it. The brown dwarf stays brown dwarf and until the end of time. This branch is finished. This branch is unclear. This branch will continue. Making any sense? This continuation of the main sequence star is what you're learning after slide 56. That makes sense. Okay. Which starts at 57. 57. Would you kindly try to understand 57, right? Well, tell me when you're done. Yeah. Nice. Okay. Okay, then you, yes, okay. Yes, then you, yes. Daniel times 3, please. This guy. Okay. Okay. So Ananya for 57, page 57. Can you explain to yourself what happened when the fusion stops lah, so to speak?
Okay. Let me process.
This is what they are interested in doing, usually the main star lah. So that's why I'm going in detail, yeah. And I believe you found the answer, yeah, Daniel? For looking good. For part 2, I believe it is it will not pose a challenge equal to 0. Please go ahead. You will find the answer like very fast. You want to differentiate. Okay, Ananya. Right. Let the question begin. So, what do you not understand about slide 57?
What's the significance of the H in the outer layers?
All right. So the point is the fusion needs H. So far, so good.
Mm-hmm.
Inside, that means the core, that means the core or the one inside will experience more gravity than the outside layer. Making any sense?
Yeah.
So the inside core will first run out of hydrogen because he's experiencing the very high pressure causing a very intense fusion. Okay, the hydrogen outside is not experiencing that, so slightly less, a lot less faster the fusion. So you don't run out very quickly. That's the some hydrogen in the outer layer. Okay, so when the inner core, when the inner core has no more fusion, gravity still works. Therefore, you have to compress it further. Nothing is stopping it. Compression happens again, gravity happens again. When you compress further, temperature always go up, not because of fusion. When you compress something, it becomes denser, a gas. And when the gas becomes denser, it becomes hotter. That has been happening since the cloud to protostar. Am I making any sense?
Yeah.
Okay, so again, just the same thing, is it? Denser, temperature go up, right? So the core becomes hotter. It simply it burns the hydrogen. Instead of fusioning the hydrogen, it burns the hydrogen in the outer layer. Okay, and when that happens, expansion happens. It is very weird, yeah. The core contracts, burning the outer layer. The outer layer burns and expands. You have a red giant. Okay, that is the part where we should try to understand. So I am taking, I'm taking out the 1 over ln 3 again. I'm taking out the 1. So in that case, this question is probably not very complicated. We just have to do it a bit tedious. Now, are you confident in differentiating that? If not, we should at least try.
Maybe.
If you're not, at least let's try once. Okay.
Yeah.
At least. You may need it tomorrow, right? Okay. Again, strongly suggest that you simply ignore the 1 over ln 3. It doesn't matter, right? So 1 minus ln 3x over x squared. Again, this is u and this is v. You will be doing a very similar process. Okay. Would you please try and see how it feels like? Right. Still the same thing. It doesn't look that bad once you think about it. Yeah. So Ananya, a lot of things are very confusing. Maybe like, hey, the core is contracting, the outer layer is expanding. If you can just understand and explain that, it's enough. Look.
Took it somewhere.
Does that make any sense, Anand? That is what you need to explain red giant.
Okay.
Sorry, Daniel, I muted you just now. Sorry, would you mind unmuting?
Hello.
Yep, okay, I can hear you. Okay, so Ananya, in the Jamboard, I say, right, fusion, no longer. Gravity, right, core. Outer layer, expand. Something. So you become a red giant. There's some details on the red giant, but that's not the most important. Again, I don't think they will ask you to quote the radius of a red giant. I don't think so. The luminosity also, I don't think so. I don't think so. Okay. This is a lot. Be able to do that with this memorization. Okay, all right, okay. So he's determined to tell you all this. Okay, okay. So, this is the first time we go very detailed again in the red giant. In the red giant. Yeah. So, I'll quiz you, Hanaya. Lagi Allah, I'll quiz you. There's no other way to do it. What happened to the core of the main star when the fusion stopped? You just use your own words. No need so fancy words, man. Right? What happened? Main star, fusion stops already.
Continue to contract.
Because
Because it's
the ever-present thing.
gravity.
Yes, because there's no other reason. Okay, the effect of being compressed is
Its temperature will increase because it becomes denser.
And that temperature will reach the outer layer, right? Okay.
Yeah.
Where the outer layer still contains some
hydrogen.
Because the inner one is the one that gets spent first, right? Okay. So first of all, what will happen with the outer layer when it receives all this heat?
It will burn and expand.
I'm sorry, the what?
It will burn and expand.
It will not explode yet. It will simply expand. It will simply expand.
Yeah.
Right? This is your official first phase red giant. Officially. Yeah. Okay. Then in some cases, not every time, in some cases, the heating, remember heating makes things fly faster, right? the heating causes the remaining H in the outer layer. Some of them can actually fusion. Some of them can actually fusion. Fusion no longer counteracts gravity here because this is in the outer layer. There isn't much gravity there. In the main star, the fusion is inside the core. It will counteract gravity. No further collapse. Here is an outer layer. You don't counteract anything. You end up expanding beyond your wildest dream. The second red giant phase will be extremely big because of this expansion due to the fusion, due to the heat. Am I making any sense? That will be your slide. There will be this slide. Right?
Yeah.
Okay. And then you will continue until here. Right? So there will be three possibilities of failure. There will be three possibilities. And we stop here for the main sequence. This is the end already to produce this or this or that. Now, at this point, Ananya, like it or not, it is, I think, much easier for you to just draw a map. Would you like to draw your map right now?
Like a mind map kind of thing.
I guess that helps a lot here. I guess.
Okay.
Right. Because if I keep continuing, there'll be always new things. It's really not good for me to do that unless you are okay with this part first. Anyway, this is the one of the important things. So I guess it's worth our effort.
Okay. I'll just draw the jump button.
That's up to you. You can do it on paper and take a picture also. Yeah, totally up to you.
Slight problem.
Okay.
The graphs
Yeah.
of 3x and non-3x don't intersect.
Correct. I'm looking at. I'm thinking about it for. Okay. Now, can I confirm? Can I confirm that you actually do this in GC?
Yeah. Let me get an answer. Just checking.
Okay, I'll do it because I am also not certain one. I actually I don't have a clear idea, so I'll also do it like on this. Yeah. Okay. We'll try to solve.
I'm F is wrong.
Let me try. So we can also troubleshoot. Yeah. Currently, I'm seeing that they are not intercepting. So, since the questions say that there is, so we just try to find mistakes. Makes sense? Yeah. So we just try it. Yeah. Okay. That's the benefit of having an answer key, right? Okay. This is definitely correct. Oh, wonderful. You're finding it faster than me. Wonderful. Where is it? Finding it faster is always good, faster than me. Like, it's just excellent. I mean, I haven't found it. Where is the mistake? It looks fine.
Is there no mistake?
I mean,
I forgot to put in the 2x, Yeah, that's correct.
Oh, yeah. There's
the 2x multiplies across.
Oh, yeah. And this is a minus x. Yeah. Okay, found this one and then this one. And will that help us? I don't know. Maybe.
Yeah, it will.
Will that?
It helps.
Oh. So we may have an intersection, right? We may.
Yeah,
right?
we do have an intersection.
Oh, we do. Oh, do we have two intersections? Wait, what?
No, just one.
Turns out that we have two. One at 0, 0. I'm not sure. I mean, one at 0, 0 and one at the other one. So I'm just pasting it for us. Let's see what we can do about it. Ananya, you are okay. Ananya, let me confirm that you're doing it on.
Okay. I'm doing it on Good Notes.
Oh, so okay, not on the Jamboard. Yeah, okay, wonderful. Yeah, you do where you want. Okay. Yeah, correct. And after this, we'll talk about the supernova. Yeah. I mean, in page 68, there is some sort of summary, but this summary, I can tell you, is probably not enough. It's lacking some details. Yeah. I think it's better to summarize from the slides. Yeah. You're doing something better than page 68. Yeah. Which seems to be that guy, right? E power this over 3 seems to be 1/4. Okay. Find the x coordinate of the point of inflection of the graph. Oh, you're done. What? No, you're done. You're basically done. That's it. Will this be okay, Daniel? Wait a minute, you forgot something. Wait, what? Daniel, shouldn't there be an x here? Isn't there an x here? No? Oh, you cancel it. I'm so sorry, you cancel it. Of course, that's a good thing. No, you're a good thing. No, you're good. Yeah, you're doing a good thing. I like it. That's it, Daniel. Are you okay with this one? If you're okay, please pose the next question.
Let me see, send it over to you.
I'm sorry, you're saying? Sorry.
I'll send it over to you.
Oh, yes, please.
All right, send.
Okay, I'm putting it in. Let me. Ananya, are you okay so far? Mean and standard deviation. Okay, Daniel, remind me. Have we ever talked about mean and standard deviation?
Yeah.
Okay, how comfortable are you with this topic right now?
Not very.
Okay, let me do a very quick revision here because that we probably need. Yeah. Last on. Okay, right. So Daniel, this is already very. This requires all the basics. How do we know? Because a question that does not give you the mu and the sigma will require all the basics. I'm going to show you some of the basics. If you don't understand, you tell me, then I can go more detail. Okay.
This is under DRV.
This is not DRV. This is clearly normal.
Yeah.
Right. Which back then I told you things like, 1 sigma, 2 sigma, 3 sigma, remember?
Normal distribution.
Yeah, this is clearly normal distribution because of the mu and the sigma. He also say random, continuous random, so it's not DRV. DRV is discrete. I talk about this like this is like 71% negative back then when I was trying to introduce the topic to you. Are we okay so far? I'll continue from here. Now, if this is 71, then I know that this is around 30, 35, whatever I call this 35%. Right, around 6. And then this will be around 15%. This whole 15%. This whole thing is around 15%. Okay. Now, what is he trying to say? We don't know the mu. We don't know the mu. We don't know the standard deviation. He's giving you something else. He's giving you less than 10.3, which is average 90%. Okay. So around here. This is your 10.3. This part is your 19%. Am I making any sense so far?
Yeah.
You are a very fit person, right? So what's your 2.4? Less than 10.3, really? Oh, you are very fast. Quite amazing.
Wait, the difference
Yeah.
between continuous and discrete is that discrete is at like for a certain value, and continuous is a range of values, right?
Oh dear. No. In a continuous question like this, you can have specific values, but it makes more sense if you just range it. If that's what you mean, sure thing.
Yeah, it's like a range from here to here between this
Makes more sense in the continuous. Yes, makes more sense.
Yeah.
So even if we say 10.3, he always put it as less than 10.3. Isn't that a range, for example? Is that for DRV, you will have a table which illustrates that it's not continuous. Something like that. Fair enough. Again, this clearly shows to us that this is not DRV, right? That part should be clear first, because they won't tell you. So I'm putting this 10.3 slightly to the right of -1 sigma. Any concerns so far? Would that be okay? 19%? Okay. I'm putting the 13.5 around at 1 sigma. 13 point around there because it's around 15%. That's your 15%. So I got my bearing modulo. Okay, will this be okay so far? Okay, then I'm going to go through the next basic. If you're not okay with this, please tell me. Ananya, are you okay so far?
Almost.
Daniel, back then I say something like this. If they don't give you the mu and the sigma, they will ask you to find the mu and sigma as proven. If they never give you mu and sigma, we should go to the z-graph. The z-graph is a normal distribution graph with mu 0 and standard deviation exactly 1 and -1. This is your standard deviation. Do you remember anything like this? Because we have to use this right now.
Yeah.
Okay. Then I'm asking you to do an inverse normal. Okay. I'm asking you to do an inverse normal of 19% left tail. 9% left tail with your mu 0 and your standard deviation 1. Okay. This time I'm relying on your calculator.
So inverse normal.
Yeah, inverse normal.
Area is 0.19.
I believe so.
Okay, mu is 0.
0. Standard deviation is 1. Right. And they will give you something like, tell me what that is.
Minus 0.877.
Right.
Minus
Minus 0. 878. Okay, you keep that in mind. I'm just writing this. Now,
Okay.
isn't this making sense? It's, to the right of -1, which is how we predicted the whole thing anyway. I hope this makes some sense so far. Okay. You do the same thing with the yellow, 15%. You tell me what is yellow for 15%. This is now right here. Right here.
Yellow is 15%.
15% right here.
Yeah.
15% right here, mu 0, standard deviation 1, same thing, right? Same thing. You give, he's going to give us a number. When you're done, tell.
So 5.50 minus 1.036.
No, it's not minus. It's not minus. It should be a right here. Right here.
So 1.036.
1.036
0.36
something, which is around 1, which is again what we predicted. So far, so good. Okay. This will be a z value. It is in the z. Yeah, I know. Like I'm reviewing the whole basics for you and it doesn't make sense. And yet I'm going to say one more thing. Hopefully that ties everything. Be patient with me. Yeah? Be patient. The one that ties you is this simple formula that connects the z graph. Sorry. No, I'm sorry. Oh, correct. This is the value at z graph. I'll just call this n, right? This is the value at the normal graph. I'll put it that way. My point is very simple. Here's your z value here. Your normal value is this one. There is a connection between this one and this one, this one and this one that we're going to exploit in order to find mu and sigma according to this formula. I hope I'm making some sense right now.
Yeah.
So I'm exploiting right now. Minus 0.78, right? Equals to 10.3, right? 10.3 and then minus mu over sigma. Okay. I'm exploiting the second time. 1.036 equals to the 13.5 minus mu over sigma. Two equations, two unknown. You solve it for mu and sigma. Am I making any sense?
You get 10.2 from. Oh.
The guy in the normal graph, the guy in the normal. This one is the guy in the z graph, and they are connected to the formula, yada yada, you get your mu and sigma. This is all the most important basics, nothing else. You understand this, you're good to go. Feel free to ask questions right now. You need to. You cannot do without all this one. Cannot. These are the basics. Feel free to also try solving. This is called the x. I'm sorry. So I'm sorry. This is not n, right? This is called x. I'm sorry. Right.
This one I know.
I'm not talking about the square right now. The square is the sigma square is the variation. I'm not talking about that right now. There is no need to talk about it right now. They're also not asking you to find sigma square.
So this part here would be 1 minus inverse norm. So that'll be 0.5.
No, it's not. It's not 1 minus that. I don't think so.
Because when you don't 1 minus, you get a negative number. Or should be minus. That's the part that
Do you
confuses
mean, do you think this minus or this minus? Sorry, this is a minus lah, minus 0.78. This is, I told you to right tail, when you inverse normal, did you set it to right tail? If you set it to right tail, it won't be a
How
minus.
the heck do you write tail?
Oh, you have to answer that, man.
There's no right tail option.
Oh,
Just-
no, you're absolutely right. No, you're absolutely right. No, you're absolutely right.
It should be
Some
one
calculator do
minus
that. I'm sorry. You're correct. Just do an 85%. No? I'm so sorry. You're correct.
Oh,
Do an
yeah,
85%.
yeah. Sorry,
Do an
not 1 minus quote,
85%.
1 minus the percentage.
Which is, yeah.
Oh, because it goes
correct.
from
So,
left to right, so it'll be here.
always in the inverse normal.
So-
Yeah,
so
yeah, correct.
0.85,
Yeah,
1 minus
a
that.
very good question. A very good question. Yes. Please try that.
Okay.
So that we know, you know. Please try that. Is it correct? 85%, 1 and 0, right? Will it give you this number? Lah?
So I can wrap my head around it.
Yeah, good question. Very good question. Ananya, are you okay so far?
Mhm.
Oh, you have it. I'm sorry.
Yeah.
Okay, sorry. Yeah. So
Yeah,
this
it's
slide is the
visible.
one. Very good. Right. I'm going to put that slide there first. Ananya, I'm going to compare it with. So, yeah. So, let me check. Gravitational attraction causes large density. Oh. So solar gains luminosity. Right. Right. And fusion balances gravity. Fusion after gravity. This is what I think is important. If you can remember them, go ahead. You don't have to put it in. But if you feel that you cannot remember it, please take down these notes because you're already doing a very good job. I'm just making it more complete.
Okay. Wait, I can't read your handwriting, sorry. What do you
Oh
write?
my, I'm sorry. I'm so sorry. Right. So fusion, right? Fusion expands, right? Expand something. Gravity compresses something. They balance out. That is your main sequence. That is basically your main sequence. That's why that's the important point to address. Okay, this thing.
Okay.
We know the mu and the sigma. Okay. Yeah. Got it.
Can you solve the two simultaneous? Okay.
Yes.
So we start from there first, because the second part is another different thing, right? Ananya, tell me when you're finished adding.
Yeah, okay.
Yeah, you're solving all those things.
Yeah, okay, can.
Okay, yeah. So we have basically finished describing a main sequence star, our sun. Okay, around there. Um, for main sequence star to be a red giant, first thing first, the core contract thingy must start with the H in core is gone. No more fusion to counter the gravity and your core contracts.
Yeah, okay.
Okay, you should add that. You should add that. That's, I think, what they want also, usually.
Okay. Yep, okay. Then.
So if you see the page 68 slides, you are done here, you are done here, you are done here, correct? And this one, you're done here also, correct?
Yeah.
I guess it's nice to note this. So this one, okay,
Yeah.
red giant here basically. And then we are now talking about what happens after this one, right? There you go. So please add the luminosity to Earth.
That's the second phase thing.
I'm so sorry, what you said?
Is that the second phase thingy? Oh, sorry.
Second phase do happens here. So here. Your second phase is this one. There's further contraction expansion. This is your second phase, red giant.
Oh, okay.
Right. So your mind map should continue. You can sneak to the bottom or something. But you are now supposed to explain how from red giant go to second phase. And then after second phase, what happened? After the second phase one, you will have three possible sorry, not three possible. Daniel, you got, goodness me, the sigma doesn't make sense, right?
Yeah, I also think so.
Yeah. The sigma feels okay. Let's just check for mistakes. Let's just check for mistakes. Are you above? This is fine. Okay, good. Now, okay, Daniel, yeah. I believe if you want to do this, you're supposed to minus. Then your mu is gone. I believe that's the mistake. You're trying to plus, I believe. You're supposed to minus, right? Okay, see whether that solves the problem. No? Now when you're done adding, please paste it. Yeah.
Yeah, that makes more sense.
You get something that makes more sense. Yeah. And then you'll probably get a mu, which also makes more sense. Right? Please try that. Yeah, the sigma does feel about right. It depends on the mu. I see. Ananya, are you okay so far?
Yeah.
Yeah, makes sense.
Which is around, nice. And 11.8 plus 1.67 is around 13.5, correct?
Yeah.
Yeah. All makes sense. All makes sense. Do you understand the basics?
Yep.
3 sections here. The graph, the normal graph, the Z graph, the Z formula, and then all the calculator stuff. Normally I should, if this is not exam, normally I will ask you to do another normal question to make sure that your basics are strong before continuing to be. Oh dear. Okay, if
this paper has like 3 or 4.
Now I'll try talking about B. If B is confusing, we must go back to the basics. Okay, yeah? And yeah? Yeah. Now let's go to page 18 first, right? So far so good, yeah? And then x1, x2, x3 plus, right, minus x4, right? Minus x4 equals to, I'm sorry, greater than or equal to 20 minutes. Am I making any sense?
What the heck is this question? Okay.
This question is, that's fine. But it is kind of normal. It is kind of normal to ask this after the first part. This is a normal second part.
Binom P or binom CD?
No. Still normal. I guarantee you, still normal. Still normal. And there are ways to simply do it one. No problem one. Okay, so far so good, Ken? I'm still writing it in x1 plus x2 plus x3 minus x4, all right? Bigger than or equal to 20 minutes. Am I making any sense so far? No.
I can't see anything. I have to go up.
Oh, I'm sorry. I'm at the next page. I'm at page 18. Yeah.
Yeah, I'm also at page 18. Wait, are you talking about this?
Yeah. I'm just putting the English into a formula form, right?
Yeah, I can see it.
And yeah. Okay, yeah. Now, of course, x1, x2, and x3 is not exactly the same because there's a distribution, right? Right. But take into account the distribution. X3 is about the same as x4, right? X1, X2, X3 is about the same. X4 is about the same, actually. I mean, there are 4 average students. They won't be totally the same, but their mu and their sigma will be the same. Am I making any sense of that?
Minus.
Generally plus minus. Yeah. It's just that you will land somewhere. Some will land at 11 minutes, some will land at 12, some will land at 9 minutes, which is super cool, right? Okay. Okay. So because of it is generally the same, then I will say something like this. So it's actually just x1 plus x2 bigger than equal to 20 minutes. Making any sense? Okay. your mu is your mu is 11.8, your sigma is 1.6, sorry, 1.67. Now you can see why the question is making some sense. He's basically just asking you okay. If you take two students, how likely will it be that their total time is 20 minutes? Well, if I take one student, the likelihood is that it's 11.8 mu, right? So if I take two students, I guess it is reasonable to ask, can it be greater than 20? Well, yeah, of course. One is around 11.8. So two is already, the mu is around 23.6. Right? So I'm forming a new normal. The new normal. What is the new normal? The new normal is the mu will be 11.8 times 2, first thing first. Am I making any sense so far?
Yeah.
Okay. The sigma is what is different, right? So in your no, I cannot say in your slide. I've never seen your slide before. This is the part where it becomes very difficult to explain. You have your slides?
This.
Yeah. If you have a slide, I'd rather explain it from your slide. If not, then I'll give it to you.
I'm not really sure how to explain this.
Oh, it must be. This is not a very abnormal thing to us. This is very normal to us. And I think your slide should talk about this.
All right.
Ananya, are you okay so far?
Yeah, I'm doing the last one.
Okay, understood. No rush.
Page 19.
Page 19. There's only one. Wait. Okay, check. Oh yeah, this is the start of the slide. Not this one. No. This is what I'm talking about. Like maybe towards the end of the slide. Maybe okay, I'm gonna delete this one. Yeah?
That's all I have.
Oh my goodness, this is all the slide you have. Really? Scary stuff. Okay, so let me confirm one thing.
The second page load.
I'm sorry. It did. I'm sorry. It did. Let me just go back. Okay.
My Jamboard just crashed.
But I think you gave me the same two slides. But definitely not this one. Definitely. Oh. Okay. Go in first. Come back first. So see, they're the same. They're the same. Okay. Again, let me confirm that this is it. This is all of the slides. I haven't seen it yet. Okay. I'll delete this. This one no need. You already understand this one. You already understand more than this one.
This one.
Look at the this Z distribution is what we talked about just now. You already know this. We use this in fact just now. Make sense? And let me confirm that there is nothing else after this. By right, there is something else after this.
There's nothing else after this. It's just examples.
Okay. Then we go back and then I'll just have to give you, right? So we want the sigma. For reasons unexplained, I will go to my variation called sigma squared. Okay, this is my variation. I'm trying to find the new mu and the new sigma. This is the first concept. I'm trying to find a new normal to represent this question. Am I making any sense so far? The new mu is easy. Just like that. Look. The variation requires a little bit more work. Jadi, okay, this is no explanation given right now. No explanation given right now. Why is this true? But just know that I'm trying to find the new sigma. And I have to go to the variation. Also, no explanation given so far. In the end, even if you have it in the slide, you will be in the form of do this or do that. I apologize beforehand. Yeah? Okay. We don't have much time to explain. Wait, can I even explain it? I can explain the difference between the sigma. Okay, so I'm going to add the sigma of the first guy, the variation of the first guy, the variation of the second guy, and the variation of the third guy. The minus doesn't stop me from adding it. So what is the sigma? So this will be 4 times 1.67 square and then square root of it. So this will be 2 times 1.67 equals to 3.34. Okay, I have my new sigma. Will this be okay so far? Okay, now using this new mu and new sigma, it is now business as usual. New mu, new sigma. This is 23.6. I have my new sigma also. So just find where it is 3.3. Yeah, it's around 20. This is around 20. 20.26, right? Okay. So find this area, basically at least 20 minutes. So 20 minutes and above. Just find this area. That's all. After I find the new normal and yeah, still the Jamboard. Still the Jamboard. Are you looking at this?
Crashing. It keeps
Uh-oh.
crashing. That's not good.
Yeah, tell me when you're done. Oh, Ananya, I can see your new stuff. Good. Okay. So I'm going to delete the first one, yeah? And sorry, Nanya. Oh, sorry. Could you make it smaller again? Are you back with me?
Yeah.
So I'm going to delete this one. So basically, Daniel, we are at the new normal area, and the new normal is business as usual. Just find that area. Okay, finding the area is the normal function, if that makes some sense. Okay, so Ananya, let me clarify this. This is where the outer core flies up, basically, right? The outer core explodes, right? Finally, flies away, flies away. But the outer core, we're going to talk about the outer layer, flies away. So that means the Planetary Nebula will expose a white dwarf, which becomes a black dwarf. That means the flowchart is better like this. Does that make sense?
Yeah.
Something like that. Maybe you want to change that. All right. So Daniel, can you find this area? Am I making any sense right now?
Which area?
You're saying Ananya?
Oh, wait, are you talking? Sorry, I thought you were talking to me.
Oh, just now, Daniel. Sorry, just now, Daniel. For you, Ananya, I'm just asking you to change the mind map lah.
Okay.
Daniel, area makes sense, huh?
Yeah.
Okay,
Just
can
do
you
one,
find
one
this?
minus this. 1 minus 4.
Oh, you're using the left tail. Can, of course, you can do that. It's a left tail. And this area should be around 85 to 86%.
So I think explain one more time where the x3 went.
Oh, again.
Just one more time.
X1 is about the same as X2, about the same as X3, about the same as X4. That means X3 minus X4 is simply about 0. Making any sense? About lah. We have to talk about in the distribution. Right?
Okay.
Yeah.
Yeah.
That's what it means. Right?
Okay.
I would propose that you do another normal question if you're done with this one, because the last part, never mind. We should focus on the first part. Never mind.
So it will be one. Norm CDM.
How do you find the area? Norm C. I have yeah, normal. Not binom, not binom CDF. Just normal, just normal.
Yeah. I know. What do I put?
In your function, you'll be able to put the mu, the sigma, and the x value, right? The x value.
What's the lower bound? Minus infinity.
The low, okay. If you use, okay, we'll say this. I will say that the lower bound is 20.26. This is my lower. Yeah, I'm sorry. No. What am I talking about? Sorry, what am I talking about? My lower bound is 20. What am I talking about? 20.
Infinity.
Or actually, you can just bypass that process and say lower bound is 20.
Oh, from
lower
here
bound,
to here.
And then the upper bound is plus infinity. Yeah, if that makes sense, right? Also works, right? Also works.
Wait, 28. Okay.
Yeah.
So 20 infinity. Your sigma. Wait, what's your mu? Mu is 23.6.
Yeah.
Sigma is 2.24.
The new sigma.
From 0.859448, which
yeah, around 85%. Yeah, around there as predicted.
Okay.
So this process all depends on the correctness of this. The end of process is business as usual. It's a matter of finding the new normal and the new sigma, and that will be the same with the next question. I think lah. You have a few minutes. Your choice, look. You want to do a new standard normal distribution or
Let's
something?
do one more. I should have one more. Something right.
Yes, that's right. That's right. Ananya, are you okay so far?
Yeah, I changed the Jamboard.
We do DRV.
Okay.
Wait, no, not the Jamboard. I just changed it on my side.
Sure. Okay. You can, Daniel. If you want to, I guess you can.
I mean, we did normal, so not DRV.
Okay. Ananya, are you sending me something?
Do you want me to? I just changed like the stuff you put.
Oh, it's the same thing, right? Okay, same thing.
Yeah.
Okay, I understand. Now, because time is almost up, let me summarize what's going to happen in the next slide. Okay, in a second. So, let's agree first that the slide 68, we are basically done. We did cover all this.
Yeah.
And if you would notice in the page 77, so we advance a bit. Look at it. Look at this all up. Look at that. Main sequence star, giants, helium, flash. Maybe you're not sure what this one. Never mind for now. But Planetary Nebula, white dwarf. Yeah.
Yeah.
Okay. And this starts from 1. This is m ratio to our sun. So this is the mass of our sun. If that makes sense.
Yeah.
Something smaller than our sun, you also know what will happen. It's a brown dwarf and it is not shown here. So far, so good.
Okay.
Okay. The black dwarf is also not shown after the white dwarf. It takes too long. Never mind, you know why.
Yeah.
So the next few slides will talk about what happened when the starting mass is much bigger than our sun. For example, 10. According to this chart, 10 will not go through the same process as what you do. You will go through something that seems hopefully simpler. I don't know. The point is he'll go through something different. Once you cater this and that, you are done with this slide. That's the function of the slide.
Okay.
Okay. Do you have time to study this before we meet again on Sunday?
Yeah, I think so. Like
Then, yes,
study
you're saying
giants.
your homework is to study the other part. Look, what happens with the starting mass bigger becoming supergiant, blah, blah, blah.
Okay.
You study that, you'll make our process faster, and then we can close this chapter. Okay, there'll be a lot of questions, so please ask them on Sunday. Okay.
Wait, what's the like the axis says sequence mass, then it says m with like a dot thingy. What's the dot?
Yes, very important. M dot thingy and L dot thingy is the mass of our sun. Our sun. So our sun as a reference, something like that, if that makes sense.
Okay, can.
All right, good. I'll see you on Sunday.
Yes, okay.
Bye-bye.
Bye.
Okay, Daniel, do you have the, oh, you're sending it. Hey, wait, no, you haven't sent anything, right? You haven't sent anything? You haven't pasted anything? Oh, there you go. A DRV. DRV. Sorry, loading very slow. Let me read the question first. Okay. Oh, it's not your normal. Okay, because they don't give any limit yet. You'll notice that for a DRV, there's a generally a very specific lower limit and upper limit. Right? Okay. So what I'm going to do is I'm going to put it in the graphing calculator. I'll suggest that you do the same. This is going to be a bit weird. We don't do this a lot in DRV, but I suggest that we do that. Elliot and Aditya, I can see you. Yeah, can you hear me?
Yes.
Okay.
Yeah.
Got it, Aditya. Now, Aditya, do you know what we are doing today?
Right?
Do you know what we should do today?
Yeah, I got a time like first thing next week. I mean, other than English. So I think, is it okay if I do a campaign first? Okay.
I am totally fine. All right. So I'll follow you. Yeah, I'll follow you.
Okay.
I'm not sure what's going on here. Yeah. Daniel, but I'm going to try something. This is the graph, and this is the table. Let's try something. So a table is a more standard way of starting a DRV, right? So I guess I'm just going to do that. Right. This is me figuring out what's going on here. Elliot, tell me what's your update, please.
Well,
Yes. I think PGF might not be tested. I can't find anyone.
Apologies. Yes, Daniel, you're saying, sorry.
Sorry for interrupting. I think PGF might not be tested.
What do you mean by PDF? Sorry, DRV, is it? Sorry.
PGF. The thing's asking for PGF.
Yeah. That's nice. It's not normal. It's not very abnormal though. So I guess we can see this for now.
The textbook, then it's probably not tested.
We can take a bet. I mean, in the end, we have very little time right now. So you should pick and choose. If you're not studying this one, we can use it to study. If there's a risk, then maybe it's a risk that you're not willing to take right now. Fair enough.
Yeah,
we can talk about it afterwards, maybe. Okay, we'll talk about it afterwards. Okay. Good. Well, Aditya, very nice, but would you please make it landscape? Yeah, I cannot.
Yeah.
Then Daniel, even though time is up, but maybe you want one more question? Maybe. I think that helps you. Will we meet on Sunday? Oh, we will meet on Sunday. Oh, sorry. I thought we are not meeting on Sunday. I'm sorry. I thought we're not. That's why I'm a bit anxious. That's why I'm a bit anxious, right? In that case, it's okay, if you want to end now, we can still meet on Sunday, man. That's up to you. It's up to you. Okay. All right, then. I'll see you on Sunday. Yeah. Okay. Bye-bye, Daniel. Okay, good. I can see you now, Aditya. Very nice paper. Right? Elliot, please give me your update.
Like I tell you, or in the Jamboard?
I expect not a lot. Maybe you tell me first.
Only had like one AMath lesson this week.
Understood. Yes, because of the holiday.
We just went through the homework because a lot of people didn't do. Then the teacher just like scold a lot of people up. Most of the lessons were taken by that.
Scolding, yes. And you are the lucky one or the unlucky one which has to go through the scolding?
No, I did it.
Of course, of course. Okay, understood. So I hope you are happy, not because you are not scolded, but because you are a responsible student.
Yeah.
Very good. You don't have the answer key yet, right? So as in, do you have some confirmation where you're correct?
Like in the PDF file for the homework, at the end there's the answer key.
Oh, you already know whether you're correct or not. I
Yeah.
keep forgetting. Oh, that's good for you. Good for you. Good. Let me confirm that your teacher will not go through binomial after this whole thing, lah, right?
Yeah, I think after going through the homework, then she'll go to the next chapter.
And going through homework means he will take another 1 session, another 3 session. What do you think will happen?
Should take one. It's like
Hmm.
one, maybe yeah, should be one.
Okay. So tomorrow, lah, no?
Tomorrow for my school is like sports day.
Oh yeah. Every school does that. Sorry, every school simply does that. Right? Understand? Okay. So we are ahead. If you're at peace, can we continue with the circle and I'm sorry, the coordinate geometry thing? If you're at peace,
Yeah.
then let's do that. Let's go to the previous Jamboard section. Aditya, are you stuck?
No, I'm just. Yeah, I'm not stuck.
Understood.
Yeah.
Again, this is tuition. If you want to, you should skip the easier ones, in favor of what I can help you with, right?
Yeah, I thought
Uh,
since it's a R15 paper, so I can like do everything.
Sure thing. For now, that's fine. So Elliot, I'm just back to the previous Jamboard here. Oh dear. Well, sorry, loading very slowly. Okay, for some reason, my Jamboard is loading very slow. But what I want you to do is very simple. Look at the questions we have gone through. Revise it. I'm going to ask you to close later and quiz you on how to do it. Meaning you're going to say to me instead of doing it. Okay? Try not to memorize too much, try to understand. Now, before I quiz you, you ask me questions first. Maybe questions will pop up. Understand? Okay. I'm not trying to promote you memorizing things. Okay, that must be done, but I'm trying to promote your logic. Okay. Finally, my Jamboard is up, but you look at the questions first. We're talking about the questions starting from page 13, I think. Yeah. Okay. Go through the page one by one. 13 first, no question. 14, no question. 15. Congratulations for being a good student. You know, Elliot, currently, you are a good student. Do you know that?
I guess so.
It's a good thing to be proud or be pleased about. Right? It's not kesombongan. It is the appropriate thing for you to do to do a good student. Okay.
Yeah. Can you go through the two right angle triangle method again?
For which page?
The 16.
16. You're okay with 13, 14, 15?
Yeah.
Okay, yeah. Okay. Let me ask you to look at page 13 first, because I did a triangle there also. Okay, yeah. Are you there? Page 13.
Yeah.
Okay. So let's repeat this. The two triangle thingy is to find a line or a point.
A point.
A point, not a line. Yeah. So one more time, for a line, you only have two methods. Those two methods are enough. What are they? 2 points or 1 point, 1 gradient. Understand? That's enough for any line.
Yeah.
Easy one. For a point, you need various methods, right? The reward is points are in general much more useful than lines. So I guess having more methods doesn't hurt. Again, let me repeat this. Once you find a point or 2 points, things are going to be very easy. So it is hard to get there. And there are more methods to consider, more situations to consider. So high trouble, but also high benefit. Okay, I'll put it there. Now, this is one of the methods to find a point. Let me explain to you this way. It requires you to usually have 2 known points to form the known triangle. Do you understand me?
Yeah.
The known triangle must obviously be formed by 2 known points. So you must have something that you know first. In fact, 2 known points. The third triangle will contain the point that you want to find out. If that makes sense?
Yeah.
And one more known point. The one more known point can be, the same point or different point, whatever. The point is, the second triangle cannot be 2 unknown also. That also does not work. It doesn't work very well. So it doesn't work. Just put it that way first. First triangle, both point known. Second triangle, 1 point known, 1 point unknown. Do you follow?
Yeah.
So when I'm trying to find S, I better find Q first using other method. Make sense?
Yeah.
As for M, I already know. No questions?
Yeah.
Okay, you go to page 16 first. Aditya, are you okay so far?
Yeah.
Now, look at page 16, Elliot. Maybe you ask yourself, how do I find the 2 triangles? Maybe that is a good question. I'll give you a different answer. My answer to you is, whatever your first triangle is, it will be between 2 known points. And whatever your second triangle is, it will be between 1 known point and 1 point that you want to find. So far, makes sense?
Yeah.
The third thing is that the 2 triangles must be related in the sense that they can help each other. So if I were to give a comparison, if I make the second triangle the blue one, that's nice, but the red and the blue one doesn't help each other. Does that make sense?
Yeah.
Maybe seeing the connection between the 2 triangles is hard. However, keep in mind what I say to you first. First triangle, both known. Second triangle, 1 known, 1 to be found. They have to relate to each other. Now, in the case of page 16, the relationship is they are the exact same triangle. So they can help each other. Am I making any sense?
Yes.
The page 13 also happen to be the exact same triangle. So they can help each other. Am I making any sense?
Yeah.
That's called congruent triangles. Am I okay? EMAT?
Yeah.
Therefore, congruent and similarity. The triangles can also be similar, not congruent. Those are the 2 relationships that you exploit. It's just either, is what I'm trying to say.
Okay.
Is it as easy as that? Well, no. First of all, I have seldom see teacher use this extensively. I seldom. Why am I teaching you and everybody else this? Because this is crazy fast after you know what to do, after you can see things. Like the fastest thing ever in a situation where most other methods are long or hard. So it has its benefits. If I teach you right now, maybe more likely you'll use it because your teacher, some teachers just don't teach. I've never seen a teacher who teaches this in my tuition, right? It doesn't mean that no teacher teach. It doesn't mean that. But I can guarantee you it solves a lot of problems. I'm trying to motivate you to give it a try. Okay?
Yeah.
Is that enough explanation or you want?
Yeah, I think it's enough.
All right. Can you apply it? Don't know, but try lah. Try your best lah. Congruent or similar.
Yeah.
One more thing. This congruent and similarity method will be used for other topics in AMAT also, which are very visual. Therefore, it is to your advantage to apply it. It is. It is. Really is. Really. Okay?
Yeah.
All right. Ask more questions. If not, then... Oh, then you do page 19, right? Page 18, right? Sure. Then ask questions lah. If you are stuck.
So I do page 18 or what?
You tell me first whether you have a plan for a page 18 or not. You describe to me your plan for part 1. Something like this, huh? First, you go find this by using this. Then you go find this because you use this. Or I need to find this, therefore I need this. Then I go find that one first. That kind of thing.
Oh, then
I see.
Find the line BD first.
Okay, by using
by using the
which method? The 2 points.
Yeah,
you just
the
say
2
that line. 2 points. Okay, you found the line. I agree. Then what?
Then you can invert it, right, to find the
perpendicular gradient. Maybe just ask something. Okay. Then for what?
Then we find the equation for AC.
Because you have 1 point and 1 gradient.
Yes.
This comes from your EMAT knowledge of kite. That was what you're missing back then. Once you know, you can do it. Okay. So your basic methods are great because you can see the plan. Back then, the only lacking thing is that you don't know kite well enough. Correct?
Yeah.
But that's fine. You can see the plan. I'm trying to train you for that. Now, what do you do to find coordinate C? Plan.
You
think about it for a while. It's 5 months, so it's a little bit of a challenge. Okay, Aditya, if I may ask you.
Yeah.
How come your new graph seems to be faster than the original graph?
Because it's it's powder now, not a chunk.
Okay. So faster rate, I understand. How come it ends at the same line as the original?
Because it has the same amount of limiting reactance.
You sure, yeah? You sure about it? Okay, sure.
Yeah.
That is 5 gram and 50. This is 2.5 and 50, you know. Who's the limiting one?
It's HCl.
Are you sure at 2.5, the limiting did not change? Because he changed the CaCO3, which is not limiting at first. Are you sure at 2.5, it is also not limiting? You understand what I'm saying?
Yeah.
Plan, Elliot? Plan? Yes.
When
Elliot.
it's 2.5 grams, it's like exactly the amount that's needed.
It will be exactly the amount needed. Oh, so it's fine now. It's fine now.
Yeah.
Okay.
Yeah.
Just to you know, just to give you a heads up lah, because it may change, right? The limiting may change. Okay.
Yeah.
Okay. Good for you. So far, you're correct.
Okay. Thank you.
Elliot, plan. Oh goodness me.
Oh no, God.
Oh, it's very easy to find ceiling. Oh goodness me. Why is that 5 marks? Okay. What? Okay, so Elliot, that is what you want to study for, lah. Like, can you plan yourself? If not, you'll be going through a jungle, lah. So I hope to, you know, shine light to the jungle. Now, there's a reason why I say C can be very easy, right? I'm a bit surprised, lah, right? It relies on an assumption. I assume that this is horizontal. However, there is an assumption, right? Because it might not be correct.
Yeah.
It looks horizontal, but I am at some doubt. Maybe he's fooling me. Okay. Now, if I assume it is horizontal, it will be too easy because C is now half a point, not 1 point, not 0. I know half of it. Okay. You tell me what's the half that I know?
The Y.
Minus 1, and you call this XC, correct?
Yeah.
Remember, if you have half a point and you have a line, you have the point. Do you understand?
But that wouldn't be 5 marks, what?
Correct. So I have reasons to doubt. But you know what? I am going to do that first, you know, just because it's stupidly fast, right? So there's a reason to doubt, okay? But I'll do that for now. And then I'll move on to the more appropriate way. So now you know that this is not appropriate, okay? You're just assuming, right? Then what is the more appropriate way of doing things here, Elliot? Certainly you must have some guesses, right? Hey, no guess.
No.
Okay. Now, here's your quiz, right? What are the 3 methods to find a point?
Is the y2 minus y1 over x2 minus x1?
That's a gradient. That's not finding a point. Yeah, to find a point, you start with what you have first. At least start from there. Then you can quote the formula. What do you have?
2 lines.
2 lines. Okay, 2 lines intersecting. Okay. That's one way of doing it. Another way is?
Half a point in 1 line.
All right. And then one more is the triangle method. Right. So obviously, I don't think you can use the 2-line method for C. At least not directly, right? That's obvious. Okay. If we don't rely on the assumption, we also cannot do one line and half a point. And I don't think we can do triangle right now. Fair enough?
Yeah.
The point is we cannot just go direct C. You have to accept that in a 5-mark question, right? I have to go somewhere else first. That's the whole planning thing. So you cannot go direct C. If that's what you've been thinking, no wonder you're confused. You understand me?
Yeah.
Okay, then go somewhere first. What is a reasonable guess for that somewhere? You think for a while. Aditya, the third experiment, can I see your n line one more time?
Yeah.
Your n line is... Does this mean that your n line is lower, correct? Your n line is lower, indicating that there will be more gas produced, right? Indicating more mass
Oh, it's
reacted,
the
so
other
to
way
speak.
around. It has to be like halfway up here.
Correct, because the limiting change to the acid, right?
Yep.
It will limit, yeah. Oh dear, yeah, okay. Yeah, a bit mistake, yeah. Careful there, yeah, careful there. So the graph is a little bit tricky, okay?
Yeah.
Do be careful. Good. Elliot, what is maybe another thing that we can find first before finding C? Make some guesses. It's okay. Elliot, make a guess.
Maybe.
Find what first? Maybe, yes, say maybe, yes.
Maybe what line? DC.
Line DC. Line DC. But using what method? To find a line, there are only two methods, right? The 2.1, which is not available here, correct? Because you see you wouldn't. That means you can only rely on finding a gradient, and you find the gradient of DC.
No.
To find a gradient, you have three methods, right? 2 points, not available, parallel or perpendicular. Once you run out of methods, for now, you can safely assume that it cannot be done. Elliot, it's not a bad news to know that it cannot be done. It might be a good news. Do you understand what I'm saying?
No.
If you know that DC cannot be done because simply you run out of methods, then you know to look elsewhere instead of just circling around without any direction. You're eliminating the option. That is a good news in itself. Do you understand what I'm saying?
I think so.
So you eliminated DC because you know you cannot find its gradient. That's it, you run out of options already. So instead of assuming that you are silly or you're missing something, maybe you should simply say, can I try something else? It's not a necessarily bad news thing. You understand?
Yeah.
Try something else then. Aditya, you okay? Yeah?
Yeah.
And see that it's correct. The graph looks fine. So you show that the limiting now changes to acid and it is now half. Oh, it is obviously it is, right? Because the CaCO3 now increases, right? Yeah, obviously. Yeah. Good. So your basics are there. You just cannot break.
Yeah.
Right. Elliot, your next guess, maybe, try what?
Maybe if AB and DC is parallel, then just find the line AB.
But AB and DC is not parallel. First thing is, they don't tell you, right? That's fair.
Yeah.
Secondly, that's not a kite. If AB and DC is parallel, you will get a parallelogram. So confirm AB and DC is not parallel because it's a kite. Will this make something?
Yeah.
Try again. I want you to try multiple options. That's what you'll be thinking, isn't it?
Then just assume that the line BC is horizontal.
But wait, we agree that that's too easy. So it's suspicious. You should try that, but there is another way of doing it, which is definitely longer, which does not require assumption. Look, to be fair, you haven't touched that one thing, You haven't tried that one thing. It's staring in front of you, but it's not, you're not even mentioning it. My point is you haven't run out of options. A large amount of energy.
Is it the perpendicular lines?
No, the point M.
Mr. Collapses is correct.
I'm reading actually. It's a little bit confusing for me. I'm gonna copy it and then I'm gonna put it in a Jamboard with my comment. Will that be okay?
Yeah, sure.
Okay. So I'll go ahead and do the. So Elliot, you have not even mentioned point M. Can it be an option? Elliot, what are you thinking? Tell me.
Yes.
Okay.
Like that time I thought about that, but then I see the page 13, then also have point M, but is like not really used. I don't know.
You mean you're looking at another question, is it? Sorry.
No, I'm looking at like the way it was used in like past questions.
Oh, right. Hey, each question is a bit different. To be fair, yeah. Fair. Right. Maybe I'll put it this way. To be fair, you are running out of other options. Correct? It's not that you haven't considered other options. Okay, fair to say, right? That means you have done your due diligence. You're not being lazy. You're trying stuff. Hey, cannot means cannot lah. I'm running out of methods here. Right? And then so you're stuck with MLOC unless you have another option to try. Aditya, are you okay with this question? This is not the easiest thing.
Yeah. The
Okay.
definition of equilibrium. I can't remember it.
Right. The rate to the left is equal to the rate to the right.
Yeah, that's it.
Something like that. Something like that. Okay. So Elliot, maybe I ask you this way. If you have M, if you have the coordinate of M, does it help you to find C?
Oh, I mean, I don't really see how it'll help.
Yeah, that means the motivation is low. Lah. If I don't see how, I don't find it fair, right? Fair.
Yeah.
Okay. So I'm pushing you in this direction. Okay. If you have M, never. What methods can you use to find a point? There are 3 methods. Okay, one more time. Say it out again.
Use when you have like half point and one line.
Half point one, yeah. Which is we tried doing that and it requires assumption. So that method we try and it is not available to us because it requires assumption. So far so good, correct?
Yeah.
Now, what's the other 2?
The triangles.
The triangles there, and before that is the intersection between 2 lines, right?
Yeah.
You wanted intersection between 2 lines, right? You wanted that, isn't it? And you cannot have it.
Yeah.
Correct or not? You're left with one possible method, triangles. If you have M, can you triangle? If cannot, then you really run out of option. Not gonna blame you. But please make sure first lah. Can you use triangle if you have M?
Yeah, I think so.
Oh wait, so M is useful. That's what you're thinking right now, right?
Yeah.
Can you find M then? That's a motivation, all right?
Yeah.
Go and find M and use your triangle. Okay?
Okay.
Aditya, are you stuck?
No. No.
Okay. Aditya, now that I read it, I think I'm okay with your boiling point. That's the previous one. Now, okay. I don't think it's missing anything.
Okay.
Elliot, what methods do you use to find M? We have 3, right?
Yeah.
Which one you think?
The 1.19.
1.1 line. No, there is no method 1.1 line. One minute.
Wait, oh,
Half a point, you mean half a point. And you don't have the half a point of M. You don't. Again, to find 1 point, you can use half of that point, half of that point with 1 line. Or you can use what?
two lines.
Okay, just to confirm, do you have 2 lines here? Can you use it 2 lines to find M?
I mean, we have 2 lines.
Which is AC and
AC and PD.
if you intersect them, will you have M?
Yes.
Then what do you think?
Then can use
Okay. Okay. Now, what makes you doubt just now? Any idea what makes you doubt just now?
No.
All right, then give it a try. Are you okay, Aditi?
Yeah, yeah.
Okay.
Just
Is this thing confusing, Aditi?
yeah, this is organic chem, right?
It is organic chem.
Okay.
Mhm. Oh, it's not in the exam.
Yeah, we didn't learn it yet.
Oh, sure thing. Okay, let's skip. Okay, question 4 is not okay.
When you invert the lines, both numbers also get inverted, right?
Yeah, you basically flip the fraction and flip the sign. Okay, flip the fraction, flip the sign.
Mr. Phillips,
Yes, Aditya.
one use of sulfuric acid would be
Oh,
carbon.
one use.
Oh no, that's lithium.
Car battery? Yeah. I guess so. I guess they still use them. In fact, I do not know anything else rather than being a good ingredient, right? Huh. Yeah, I guess so. I guess so. That's fine. That's fine. That's fine. The answer is correct. Okay. Aditya, to a more appropriate phrasing, yeah. So you cannot just say car batteries. At the very least, say to manufacture car battery. More appropriately is the electrolyte in the car battery, but I don't think you are required to know until that level. So at least to manufacture car batteries. Okay.
Okay.
So it turns out that there's a lot of use. So another use that you may want to know is for cleaning products. The
Okay.
ingredient in cleaning product. I guess it makes sense because you can use some dilute acid to clean stuff. Elliot, are you okay so far?
Yeah.
Are you at M?
Yes.
Are you applying triangle?
No, not yet.
Okay. If you're stuck, please ask, okay?
But can I check the answer?
Of course you can. No, of course you can. Okay. But why would you check the answer before you find C?
Oh yeah. So
Right.
Kak, but
Yes.
when you say invert, it's really just invert, right?
Are you talking about the gradient?
Yeah, because my number like a bit weird.
You tell me the M. What's your M?
Here's my
Okay, now first of all, what is your line AC? Okay, maybe you just tell me your line AC. I guess you can check answer key for line AC, look, I guess. Maybe
my
that's
line
easier. Yeah, AC, yes.
my line AC is y equals 6x minus 6/5.
Minus 6/5. So this is definitely not correct. Why? Because this gradient is definitely a negative gradient, right? Not a positive one. Is that?
Yeah.
It's a very steep negative gradient. So the 6 may make sense, but it needs to be negative, right? Secondly, the minus 6/5 is also doesn't make sense. So the y-intercept is like way up there, man. Correct? Way up there. It's definitely not minus 6. Okay.
Yeah.
So tell me, what's your gradient of BD?
My gradient of BD is y equals 1/6x plus 5/6.
Sorry, say what? BD is what? Sorry?
1/6x plus
1/6x
5/6.
plus 5/3. Now,
Six.
the 1/6 seems fine, right? The gradient seems fine. It's a positive gradient. It's not very big. This is a y-intercept. Your y-intercept is clearly -1. So what's going on here? Correct or not?
Yeah.
Secondly, turns out that the gradient is also wrong. Look, yeah? Rise over run, right? What is the
Yeah.
rise? What is the rise?
3,
Yep. What's the run? Obviously.
6.
So the gradient is are you okay, Aditya?
Yeah, just opening up the answer key.
Okay. That's fine. Balancing it correctly. Okay, Elliot, what's the gradient? The rise is 3, the run is 6, right? So the gradient is
3, 2.
hey, come on. The rise is 3, right? The run is 6. So the gradient is
3 6, yeah. Rise of, yeah.
half. The gradient is half, right?
Yeah.
Okay. So you will rely on formula. Do you check your formula again? Check your formula. Good, good, good. Come on, Elliot, you found a mistake? Elliot, wait, Elliot, I cannot follow you. Come, you tell me. Have you found the mistake or not?
No.
Okay, tell me, read for me what you did.
Wait, yeah. I found
Right.
a problem already.
Y2 minus Y1, right? X2 minus X1. Your problem must be above, right? You write 2 minus 1, right?
Yes.
Now, this is not how I teach you. I teach you to rely on your visual sense. Of course, you have to write down the formula lah. But I never teach you the importance of formula from the start. Nor do I think right now formula is more important than your visual sense. You remember just now I asked you, what's the rise? You immediately answer 3. Correct or not?
Yeah.
If you rely on your visual sense can correct your application of formula. This is not the first time you make this mistake, by the way, when using the formula. But this is also not the first time your visual sense is correct. Your visual sense is strong. And that's how I am training you.
Then when do I know to use when to use the visual and when to use formula?
You always use the visual sense. Always. That is what I teach you. The formula is there for presentation. They both better match each other lah. I'm not saying that the formula is inferior to the visual sense. No. But I'm saying that they should match each other. You shouldn't put too much faith in the formula only. Especially not when your visual sense is strong. And to be fair, your formula sense is a bit weak lah. To be fair, right? Correct or not?
Yeah.
You cannot just rely on the formula. That's a very bad idea for you. For other people, maybe that's good. Now, Elliot, which one do you prefer? I just train you purely on formula? I mean,
No.
is that what you prefer? Okay, then why do you do that? Why do you just rely on formula?
I mean,
Right?
since like the start of learning any point related, they always just teach formula. Then
Yeah.
using
Huh.
formula off habit.
No, I know that's how they teach you. That's why I ask you. That's why I ask you. Do you want me to train you in formula only? You say no, correct?
Yeah.
Why do you say no? Why don't I just do what other teachers do? Isn't it better? Keep repeating the same thing. Why do you say no?
Because this question I use formula, then it's wrong.
Well, your formula sense is wrong. Not wrong, weak. Doesn't mean that other people is weaker or stronger than you, or whatever. Other people is different than you. Whatever, To be fair, yeah, the teacher's sense of formula is very strong. Correct or not?
Yeah.
Well, your sense of formula is not very strong. It takes time to make it strong. Right? So again, you still haven't answered my question. How come you say no when I ask you, should I just train you purely on formula? I mean, it has to be stronger anyway, right? Why do you say no? You haven't answered that. Aditya, are you okay so far?
Yeah.
Yeah, that's all. Yeah, that's fine. That's all great. Yeah, that's correct. So you're very comfortable with your solubility. Is that true?
Yeah.
Good. Come on. A bit more. Let me see. Your questions are also not the easiest thing, right? So I like it. Okay.
Okay.
Elliot, so why? Why do you say no? No, I don't want to be just trained in formula only. Why not?
This visual feels faster.
It is. Has always been. Your visual sense find the answer first. However, you cannot present your visual sense. Or rather, I won't teach you to present your visual. There is a way. Then you will feel very uncomfortable because your presentation is extremely different from your teachers. You will always have that doubt. But it doesn't mean that you don't have a visual sense. Your visual sense find the answer first, and then your formula usage needs to match that. If it doesn't match, one of them is wrong. Just find out who is wrong. Do you understand what I'm saying?
Yeah.
So if you want me to teach you not just by formula, then you should at least use your visual sense. What? Make sense or not? It doesn't make sense to say you want to be trained like that, but you don't use it. Plus, you know that your visual sense is rather strong. If your visual sense is weak, by the way, maybe we shouldn't be touching that, right?
Yeah.
So, are you settled in this method? Are you okay?
Yes.
Okay, use your visual sense, make all the corrections needed. You can assume that they are not the same, Aditya. You can assume for now, but you are right, your logic is also correct. They might be the same.
Okay.
Y is more reactive than Z. Oh, now you're suddenly. Wait, what?
Oh.
Huh? What is you are? Elliot, are you okay?
Yes.
Okay. Tell me the new. Sorry, write for me. Just type. Type the new co-equation of AC. Yeah?
Okay. Page 18, right?
I believe so. Oh dear. See, your formula sense is weak again. See, you make another mistake again here. Can you find your mistake? Your formula sense is weak, but the weakness is like the same thing. It's a minus problem again. For some reason, that's your weakness right now. Fix it. Oh, he wants to give explanation. Oh. Ah, uh, uh,
I mean,
okay,
it's still
Aditya,
not.
maybe in this situation, maybe you will code the reaction, maybe lah. I mean, your answer is definitely in the correct direction, and your logic is totally fine. Maybe to complete, you code the reaction. W displays Z reaction 1, right? Which displaces Y, which means reaction 3. Yeah, that have to. Maybe that's the most complete thing. That's fine. That's fine. Elliot, have you found your mistake? Oh, there you go. There you go. So same problem as just now, right? Different formula lah, but same problem, right?
Yeah.
Right. So the weakness should be fixed, but I would say that you at least know what is the problem. Okay, make it so. It looks good. Find your AC, please. This is still your BD. Last question. Okay, sorry. Just now, the last question. Okay, Aditya.
Yeah.
Okay. Okay.
I don't know why
All right.
it like went off the line, so I just cancelled it and wrote it again.
Right.
For neat
Sure.
sake.
Yeah. If you're okay, then all right. All right. Good. 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 So far, so good. Okay, let's try this.
Mr. Philip,
Yes, sure.
how would there be any current in this without a battery?
Oh, dear. Okay, that's a foundational question. Let's answer that. Okay, let's see how far we have to. Okay. What chapter is this?
Electrolysis.
Okay, then let me ask you. You're right, though. You're right that this chapter is electrolysis. Now, is this page 10? Yeah, page 10. We'll go to page 10.
Okay.
Right. So, is your question like this? How can this be electrolysis without a battery? Is that your question?
Yeah.
The answer is this is not electrolysis. This is the reverse of electrolysis, which is in the electrolysis chapter. If it doesn't ring a bell, does it ring a bell?
No.
Okay. Processing, yeah, processing. This is now we're now learning. But maybe we're learning something new. I don't know. Yeah. Now you think carefully, yeah. Electrolysis, the input energy is what?
Sorry?
The input energy.
Yeah.
Is what? The type of energy that you need.
Electric.
Totally fine. And the output energy is what? If you think about it.
Chemical.
Very good. In this case, the input is chemical. The output is electricity. This is called a cell. Not an electrolysis cell. It's a very annoying word. They shouldn't be using the word, but never mind. This is a cell, also known as a battery. A battery. This is the battery. This is the battery that you have in your remote, in your whatever. Let me try to put it another way. You have a power bank, yeah?
Mm-hmm.
What do you expect out of your power bank?
It can like charge my phone without having to put it in a socket.
Okay, so you expect the battery bank to give you electricity. Inside, surprisingly, there isn't electricity. There is chemical reaction going on. How do I know? You have seen all the video of do not puncture your lithium-ion battery, right?
Yeah.
If you puncture your battery bank, which is very likely a lithium-ion battery, it will go smoke, go fire, and maybe explode. That is the proof that inside there, chemical stuff is happening. That is why you cannot put your battery bank larger than certain limit in your luggage or in your plane. If that explodes, maybe people will get killed, from all the smoke. It's not the plane is going to blow up, but from all the smoke that's going to be caused by that. Okay, so far so good?
Yeah.
So your battery bank is a battery, which is very similar to what you're looking at. You expect your battery to be able to light a bulb. Now, you also charge your battery bank.
Yeah.
Okay, when you charge it, it becomes full. When you charge it, it is undergoing electrolysis. It is eating electricity, and inside, some chemical reaction is happening to recharge the battery bank. That is electrolysis. Electrolysis and battery are a reverse thing. In your hand, battery bank, it will sometimes perform electrolysis if you ask him, and it will sometimes perform battery if you ask him. Am I making any sense right now?
Yeah.
So no wonder an electrolysis thing and a battery thing in front of you looks very similar. Hey, it's the same thing. It's a battery bank. The difference is the way we try to understand it. One more time, they look extra similar. They are almost the same thing, but it is a reverse of each other. Can you accept that?
Yeah.
Now, all this sounds new, isn't it?
Yeah.
Oh dear. So foundationally, I have explained to you battery. Okay, are you ready?
Yeah.
Before that, Elliot.
Actually, I think
Yes. Yes.
the syllabus changed, right? I think this was removed or something.
For local, definitely not. For you, you do have to confirm that. Maybe that's the case. Maybe that's why you're fully blank. It's a good suspicion. Can you confirm that?
Yeah. I
Okay.
asked one of my friends, I'll look at the syllabus.
Sure. We can wait for now. Okay. You decide what to do. Elliot, are you okay? Are you stuck?
I'm okay.
Okay. Tell me what's AC right now.
AC is y equals negative 2x plus 9.
Plus 9. The negative 2 seems to make some sense, yes? Yes or no? Agreed. Yeah. The 9, does it make some sense?
Yes.
Okay. Then let me ask you. I'm actually requesting you to use your visual sense, ma. Hey, negative 2 makes sense or not? Visually, right? +9 makes sense or not? Visually, lah, right? What else is there, right? That's what I'm training you. Did you do that before I asked you? Did you do that before I asked you?
No.
You get what I'm saying?
Yeah.
You must get the training. I'm trying to train your visual sense. Don't just be happy with your formula. Let's be fair. When I ask you to confirm visually, do you feel happier? Happier, sorry. Do you feel happier?
If it's the same, then yes.
If it is not, then you are less happy lah. Okay,
Yeah.
fair lah. But that means you know that something is wrong, what? So that's a negative morale, fair, but there is a positive thing to it lah. You know something is wrong. Now imagine that happening in exam. I'm not there. You remember what I trained you. I whacked you so many times. Use your visual sense. Hey, you remember it. You use your visual sense. You realize something is wrong. Your morale is down. Is that the end of the story?
No.
Can you pick yourself up from there?
Yes.
Whereas if you don't even realize that you're wrong, what happened to your 9 marks?
All gone up.
Not just that, you will spend a lot of time blowing it all up. Correct? Because nobody skips correct geometry. You'll see later on. But a lot of people do a lot of things and still don't get much marks. I don't want you to be like that. Do you understand?
Yeah.
It's not that you just lose 9 marks, okay? You lose 9 marks and also you lose time. That's double bad. Might as well just skip this question, but nobody will skip this question. Nah. So you get it right. Use your visual sense. Okay.
Yes.
Okay, get your M, please. Aditya, what's the... Okay, there's a conclusion. We don't worry about this.
Yeah, we only learned like normal electrolysis and hydrogen oxygen fuel cell.
Wonderful. Which is to say part B, though. Yes?
Yeah.
Okay. Oh, you do learn hydrogen cell. You do. Oh,
Yeah.
oh, okay. All right. Okay, understood. Okay.
But how do I apply the visual sense into the equation?
You don't apply the visual sense into the equation. You just use your visual sense. It's a different method than the formula. The only thing important is that both of them should point to the same thing, at least to the same answer. Do you understand what I'm saying? The formula has its own way of thinking. One visual sense has its own way of thinking. That means you're applying 2 methods, right? I'm forcing you to apply 2 methods. Contrary to what people may think, it is actually much faster to do 2 methods in this situation, not slower. That one I can guarantee you. At least it's faster towards the correct answer, lah. At least, lah. Right? That's what you want, right? Fastest towards the correct answer, not fastest towards an answer. Right? So no, you don't apply the visual sense to the formula. Visual sense is a totally separate thing. Just think about it that way, lah. Now, does that help you?
But I don't know how to get the
M.
Yeah.
Wait. The method is not a visual sense, okay? I keep asking you, right? To find a point, you have how many methods? Come on.
I have 3 methods.
Yeah, which is go through, man. Yeah, come on, go through it.
The triangle,
Can you do it here?
Not for the M.
Okay,
Then half point one line.
can you do it here?
No.
Because you don't have half M, right? Simple, right? Okay, then
Then 2 lines.
can you do it here? Because maybe the answer is not lah. Can you?
Yes.
If the answer is yes, then you do that, right? If the answer is no, then you have eliminated all options. Not necessarily a bad thing to do. Understand?
Yes.
So why are you not using the 2 lines to find M? There is no visual sense there, though. Using a form, it's going to be using 2 lines. It must be some sort of formula or method lah, must be lah. But you can confirm the answer later using your visual sense. Am I making any sense, right?
When the time you said my line AC, like the +9 got problem.
No, your line is 6x minus 6/5, right? Your 6 got problem, your minus 6/5 got problem, correct?
Yeah.
Now your answer is -2 plus 9. I asked you just now what? -2 makes sense or not? You say?
Yes.
+9 makes sense or not? You say?
Yes.
I agree with you. That's why you're happier when you use your visual sense. What? You use it to confirm the answer. Sometimes the visual sense arrive at the answer first. Then the formula kind of matches lah, hopefully. Sometimes you use the formula or whatever algebra and then you use your visual sense to confirm. In both cases, you should be happy when they match. Am I making any sense right now?
Yeah.
So, are you sure your AC is correct? 95% sure lah. Maybe something like that?
Yes.
Okay, so can you find it?
Yes.
Okay, go and find. Before you tell me, you should tell me, right? But before you tell me, use your visual sense to confirm, right? Oh, you even know the oxygen problem. Okay, okay, sure thing. You have very little time left. Can you choose one question that you think might need help? Just look through lah. Just look through. You will see a topic that you're not very comfortable with.
I found M already.
Right? Have you checked with your visual sense?
Yes.
What do you think?
It's reasonable.
Okay, reasonable is good enough. Tell me what's your M.
4,1.
4,1. Let me see. I'm using my visual sense also, right?
Yeah.
4 is between 3 and 6. Hey, makes sense, right?
Yeah.
1 is between 3 and 2. Hey, makes sense. No. 1 is below 2. I mean, it does look it looks sensible, I guess. Yeah. Okay, can you find C?
Mr. Philip.
Yes, Aditya.
Yeah, it's pretty easy. Question 6 is good enough.
Okay, and do you do what you want?
Okay.
Come on, Elliot, come on. Time is almost up. Come, go find C. Go find C. Elliot.
Okay then, Mr. Phillips, I'll call in.
Sorry, Aditya. Sorry, you're saying?
I'll leave the meeting.
Okay, you sure? You can do the bond thingy? You sure?
Yeah, it's just
Alright.
catalytic converter stuff.
No, the bond, the 6A is not catalytic converter. 6A is
the hard part is catalytic converter stuff.
Why? Sorry, why is catalytic converter hard? Sorry.
No, like it's harder than this.
Oh. But you have no problem.
Yeah, yes.
Okay, all right. Okay, then I will see you. Wait, when do I see you? I will see you on next Wednesday.
Yeah, next one.
Bye bye, Aditya. Good job today.
Bye-bye. Thank you.
Bye. Elliot. Elliot.
To find C, use triangle, right?
Okay, wait, tell me which triangle are you using. First, what is known, right? So which one?
I can
Draw
I
something.
can draw the triangle.
Draw something. Draw something. Come on. Draw something.
I think it's like this.
Yeah, yeah. Try that. Try.
It looks a bit weird.
Okay, that's a 90-degree triangle, which is straight, right? Straight, purely horizontal, purely vertical. And the first one you draw is fully known, right? The second one you draw is half known. It contains C. All good stuff, right? All good stuff.
Yeah.
And they are related in what ways? Congruent or similar, right? That's all. Yeah.
They're all on the same line.
I know. So the two triangles are congruent or similar. That is the two relationship that you must use. Which one?
They are.
You are not sure, correct?
I'm not sure.
Right. So it depends on the kite knowledge again. Back to the kite. EMAT knowledge, you're supposed to know this. We're revising, right? Good luck. Good stuff. This is supposed to be cut in half. So this is the same as that. You may have suspected that, but I'm going to confirm that. Is this okay?
Yeah.
Back to the triangles. Are they similar or congruent?
Similar.
Oh, why would you say that? No, wait. This and this is the same, right? This and this is the same.
Yes.
Therefore, this triangle is the same as this triangle. Congruent.
Yeah.
Not similar, congruent. Would that be okay?
Yeah.
With that, can you find XC and YC of course?
Yeah. I think so.
Give it a try. Give it a try.
My answer for C is 5, -1.
Visually, does it make some sense?
Yes.
So happens it confirms that the BC is horizontal. However, we don't assume that. So that's a bonus.
Yeah.
Okay. In fact, they actually asked that in part 3. The answer is BC is horizontal. So you're not allowed to assume that in part. Even though the graph seems to indicate so. So in total, what you have just did is basically 6 marks. You okay? You happy with this?
Not happy with how long it took.
Of course. But of course, I'm also not happy. But that's because I have to cajole a lot. I have to force you a lot to use your visual sense. For some reason, the moment you do it, you feel faster. Even your formula. I don't know. Is that what you experience?
Yeah.
Well, then, both senses can work together, yeah? That's what I mean, actually. Okay?
Yeah.
You'll be faster next time. Don't worry. Okay, on Sunday, there is no progress at all, right? In layman, right? Next
Yeah.
week, you'll still be doing well. So on Sunday, to nobody's surprise, you're going to do one more CG. Hopefully, you're faster, right? Hopefully. And then we go to circle.
Okay.
Okay. Both CG and circle are super big marks. You tell me, even though you're slow, this is 8 marks, man, and this is 9 marks. This is like 2 logarithm questions, right?
Yeah.
Or 1 indice and 1 log, or 1 indice and 1 cert, whatever. It's longer than a binomial question, by the way. It will always be like that one. That's just how CG is. Is it worth it or not?
Yes.
Same thing with your circle later on. It'll be super big marks. It is slightly more difficult, but if you master it, the marks are so worth it. Definitely better marks than logarithm in this cert lah, all those stuff lah, right? Definitely lah. Yeah.
Yeah.
So, I'll see you on Sunday. Good job, Elliot.
Yeah.
Bye-bye.
Bye-bye.